Australia has been a connection, but Austria we need to explore more now.
Yeah.
Awesome.
You sounded like a jank, like an American, not knowing the difference between Australia,
Sweden and Switzerland.
Exactly.
What's the difference?
So I had a short presentation for her and talked about what we do and so on.
Okay, cool. What was the actual topic then? Was it robots mainly, or?
Yeah, in my presentation it was about robotics and what we have done, a bit about my background and so on. But the day in whole was about innovation.
So that was the general theme of discussion about innovation. Cool. And how did that discussion go? Was she, I guess, a technical person?
No, I think she was into law or something like that.
And then you started speaking about, robots and how they work, or
it was not so much about how they works, but I gave examples on what we have done in the past together with Saab, together with Ericsson and other companies, and also in-house projects. And she was especially upset about the in-house projects because she
actually became upset then.
Yeah, she was asking a lot about why do you do this? Should you really invest time and money on this kind of projects? And
so what was the most fun project that you think is fun that she think is? Could you?
We had done a pizza cutting robot that identified the pizza.
This is useful.
Yeah,
this is really useful.
Exactly. And we had camera solution if it's Hawaii or Capricciosa, and also voice controlled robot, so you can talk to the robot and say I want 5 slices, and the robot will do perfectly 5 slices. Or if you are a 7 person and so on. So it's hard to do that manually.
Yeah. So you basically told the robot, I want 5 slices of pizza, and the robot can go and...
Yeah, and the robot also have a speaker, so it says, yes, boss, I will do this for you.
And she actually became upset about that.
She said that this is not what I want to have in the future, and you should not invest money in this. And I said, this is an in-house project we did in and after work, just a short project like that. But she said that we need to focus and spend time on more realistic robots, or that they...
Like what? Did she give some example?
Elder care. She said that she wants a robot that can wipe her butt in the future and so on.
Did she actually say that? Or?
Yes.
That's so funny.
But with some kind of glimt in the ögat, so to speak? Or?
Yes. So it was a good discussion back and forth, and she asked, why aren't you more into medical robots? And I said that the regulation is quite hard, and it takes a lot of money and also time to get through all these regulations. And she also asked, why can't we have robots more in this society open? And I said, maybe in the future we will see more robots in the society, but for now we need to think about the security and so on.
Yeah, and what was the main angle here in relation to Austria, or why do you think she was interested in doing this trip and talk about innovation with Swedes? So
yeah, she is the ambassador, so she lives in Stockholm.
Of course.
So she is interested in the trade collaboration between Sweden.
So as the ambassador of Austria, she stays on top of Sweden, so to speak.
Yes, and she wants to have more collaboration between the countries. And Austria is also an innovative country, and Sweden is. So she wants more collaboration between the countries.
And could you imagine, or could you talk about, did you get into those kind of discussion? What can that innovation be all about, or is that next step?
Yeah, we talked about that as well, and Saab was part of the meeting, and they was talking about the collaboration in the defense industry and so on. So we had some concrete discussions, and also she had a trade commissioner with her, and we was talking about some theaters. We can use robotics, art together, so it's not only the science part, but we also need the humanity part.
And it leads me down one rabbit hole here. How important are these types of exchanges, or is it just sort of innovation theater? Is it just inspiration? Does it lead to anything, or is it part of building up a long-term relationships? How do you see the value of doing things like this?
I think they can be great, but the biggest value is not actually talking with the ambassador, but the other participants. So me talking with other companies presenting at this occasion, I think that is the most value, at least for me, to have these contacts with other participants.
But isn't that then really then when these types of engagements, there needs to be an arena to meet, and there needs to be accountability, mandate, and trust that someone can supply, like an ambassador.
Exactly.
And within that arena now, fruitful things can happen.
So that's the main goal, that we have these arenas, and the ambassador is there and create it and make me spend time. I want to go there because she is there. Not if someone invite me, go here to this mingle, there will be cool people, I will skip it, because then I have better things to do on my agenda. But if it's something special, this was on the Castle of Linköping, a big dinner and so on, then I can take my time to go there.
Makes sense.
Was it this specific robot that you?
No, I didn't have this specific robot. I actually didn't have any robot with me at the presentation, but I was talking about different kind of robots. And the pizza slicing robot was actually a normal robot arm, like an industrial arm.
It's an industrial arm used for pizza slicing.
Yeah.
I wish I had one of those at home, by the way.
Yeah,
but I'm not going to ask you if you have one, because you don't want to answer that.
The pizza robot was actually at my home, yes.
I mean, it's awesome to have an additional guest today called Elsa, and we should do the proper introduction of her as well shortly. But before that, let me just welcome you here, Fredrik Löfgren. We've known each other not that long, like a year or two, but I must say I've been impressed every time I think we've met. Both from the knowledge you have and also your personality and the way that you can engage people. I think in my eyes, you're like a young Elon Musk in some way. And
this is huge. This is huge.
I mean, in some way, you have a number of companies, right? You are a very skilled engineer. But perhaps a bit unlike Elon Musk, you actually are a very good speaker as well. I don't think he's a really good speaker, but
I don't think so either.
Yeah.
But maybe that's his trick. Everybody, he's so bad at speaking, so he must be telling the truth.
I think the actual rhetoric is bad, but what he says is actually very profound, of course.
Yeah.
But I think you also are very good in the way you give speeches, and I mean, you've been speaking in so many different occasions in SVT and TV4 and morning news about sex robots and whatnot.
What's your claim of fame when it comes to, are you C-kändis, B-kändis, A-kändis? What's your claim of fame?
I think I'm D or something like that.
Yeah, but is it Morgonsoffan? Is that the morning show? I think that's very broad.
More people recognize me from Talang,
right.
Swedish Got Talent, and Genikampen as well. I won the first season of Genikampen in SVT.
We should speak more about that shortly. I think that's a big thing, actually. I mean, you have so many talents. I think it's truly impressive, and also that you have this kind of passion for learning. Young kids learn math, and you actually spend lots of time doing so. It shows that you also have a very strong passion and like goodwill for society and people.
I want to give back the thing that I didn't receive, so I want the next generation to have role models in this kind of fields, not only sports and music.
Yeah.
Well put.
Well, enough complaints. We can continue for a long more time here. But let's start with the first question. Basically, who is Fredrik Löfgren? How would you describe yourself?
Yeah, I'm an entrepreneur, serial entrepreneur, raised in the countryside. So I started building stuff very early, building small houses in the forest or Lego and so on. But then I got bored of playing with the Legos myself and found out that you can program the Legos. This was quite early, in 98 I think. I started programming and send this over to the Lego, and the Lego truck or whatever started to move by itself. So it was really interesting and fascinating to see that these cars can move by themselves when I was typing something in the computer.
And is this the Lego, a special type of Lego?
Yeah, this is Lego Mindstorm.
Lego Mindstorm, and it has been around since the 90s.
Yes, 98, the first generation, and now they are in the fourth. And I have been playing with it ever since then, and it's a fast type in prototyping. I can build stuff with the gears and so on, and then write some nowadays in Python, but you can of course use
we need to have
graphical.
a clip for my my sons. They are Lego nerds, and I'm trying to push them to start learning programming. And
this is a good way.
Yeah. So how advanced can you actually get with Lego? And I claim quite advanced.
Yes, I will say that it's no boundaries. No limits. You can go as complicated as you want. I have done Q learning and different AI algorithms, and you can program it in Java, C++, Python.
And push it into...
Yeah. The Lego brick, the new generation, both the third one and the fourth one are running Linux. So it's a real operating system inside it.
Awesome. And you said 98, but you're actually a very young person as well. How old were you at that time? When did you start program? At what age?
I was 6 or 7. So I'm born in 92.
Yes.
Yeah. So basically, you grew up with Lego, but not any Lego, with programmable Lego.
Exactly. And we had internet and computers in my home. My parents are not programmers, but they are technological interests. And my father had internet, I think, 89 or something like that.
That's early.
Yes, that's early. But then after that, he didn't understand what should I use this for. So it was like we had it, but he didn't use it so much. Sometimes visiting BBSs and so on. But
cool stuff. And what happened after that? So you started program, you started working with Lego. At some point, you also, of course, did some studying as well, right?
Yeah, in the junior high school and so on. Yeah, and I was programming games for my friends as well, and robots and so on. But I actually got banned from the computer hall because they said, "Oh, you can't play games here." And I was telling them, "No, I'm playing my games. I have done these kind of games." And they say, "No, it's impossible." And I tried to show them the code, and they said that I'm just joking around. So I got banned from the computer hall 3 months.
Yeah. Because you were I'm not playing the game, I'm beta testing my own game.
and I said to them, this is a future career, you can work as a programmer, and they said no, it's not a good choice of a career to be a programmer.
You started just like Elon Musk. He started programming games when he was really young. That was his first.
And you hacked more
yes, exactly. I was more a hacker, I think. But I
also hacked my teacher's computer. I changed the background image of the teacher's computer. Awesome. And so on.
Love it. Cool. And then you continued. You also did some studying in university, right?
Yeah.
Linköping, of course.
Yeah, I moved down to Linköping for the university studies. And before that, I can say at the gymnasium, the high school, I actually got an office. So I got the keys to the alarm, the gymnasia high school, and I was there in the spring break and summer break doing some inventions. I had seen on movies that you can have touch on surfaces. They had a window with touch and they can zoom into maps and so on. And this was before the smartphone. And I thought that this should be possible to build somehow. And I was thinking about it together with one of my friends. And then we come up with the idea, if you have a projector and we have a table and mirror, so we can shoot the image up to the table. And we had frosted glass on the table. We can see the image there, and we can have a camera under the table to register the fingertips. And it was a bit hard to do that in the beginning, but then we filled this area under the table with infrared light, and we have an infrared filter on the camera as well. Then we can filter out these fingers because the infrared light will reflect on the fingertips. It's not so much heat.
It's the reflection.
The reflection on the fingertips. And we can still see the image because the image is in visible spectra.
So the red, so you have infrared in order to get the spectra for the
fingertips. Yes.
Which is not interfering with the spectra of the actual image.
Exactly. And then we could play games. We had Pong and we had maps we can zoom into and other games, and also having like a...
And this was your spring break.
Yes, exactly. When I was 16 years old or something, we could have images, we passed them around like a photo gallery and so on. And this was before Microsoft released their multi-touch table before Sectra had their operation table and so on. And when Microsoft released they had a limitation on 5 fingers. But we had
10.
Yeah, more. No limitation on the number of fingers.
Because you solved it differently.
Exactly. So that's such things. I see something in the movies and then I start thinking, how can I build this? Also VR headsets. I did my first VR headset, I think, in high school. I was 17 or 18 years old with a mobile phone and gyroscope and so on.
The whole cardboard.
Yeah, exactly. Before the cardboard. Yeah.
But the fundamental idea was already then.
Exactly.
And you made it work?
Yeah, it worked. So it was nice. And then Oculus and everything with the VR exploded.
Awesome. Okay, so I know you did so many things when studying as well, but you started to study at what program was this? It was not
applied physics, because I thought that I already know how to program. Why should I study programming? I have been programming like more than 10 years when I started university. So I thought, I'm already pro on this. Maybe I wasn't, but anyway, I started applied physics because I thought that it's good to know physics as well. Yeah. And then we had internal championship in programming at the university, so internal competition between the students. And in the first year or first semester, I think I won the competition, first or second maybe. And then one of the teachers was emailing me and asking, how did you win? You're studying physics and you won over the computer science guys. And I said, yes, because I already know how to program. So maybe it was the right choice to study physics, because apparently I knew about algorithms and algorithmic programming, competition programming. I already knew a lot of things. I have been competing in different competition, like the Baltic Olympic Programming Challenge and so on, and also Swedish Programmeringsolympiaden.
Perhaps we should go there for just a second. You know, competitive programming is a bit different, I would argue, than normal programming. Or how would you describe what competitive programming is?
It's more about algorithm, how to solve problems, very limited, concrete problems in an efficient way. So normally if I program a robot, I have a purpose. The robot should bring me something, do some task. But in the competitive programming, it's more about clever data structure or a clever way of...
And what was the criteria to win in competitive programming? It is the most sharp or neat code, or the shortest amount of lines?
You can have the different rules. So there are programming competitions where you should be fastest, like writing the code fastest, or having the shortest code.
Shortest code, solving the problem the fastest.
Yeah, exactly. So there are different competition with different rules, but normally you should clear all the inputs. So you... If you don't succeed in solving all inputs, you get less score. But if two competitors have the same number of inputs that they can solve, then it's the fastest one doing that.
So what's the normal setup for a competition like this? You're given some kind of instruction,
yes,
and you have some time frame. Can you just describe the normal setup?
Today they are using computer judges. So you get the... task formulation on a paper. It can be 7 tasks or 5 tasks. Some of them are short, like 5 sentences, but some of them can be quite comprehensive. So you need to really dig into the problem and try to understand what are they talking about. And it's very clear about how should the input be structured, how should the output be structured, because we have a computer judge. No human will be interfering in the judging process. So you need to really read how many lines should you read from the standard input, how many lines should you print out, and so on. And then you start programming, and you can do it in different languages, Python, C++, Java, or whatever you want. And then you send in your source code to a web interface, and they will compile it and run it, and you will get an answer. For example, you succeeded in 5 out of 10 example inputs, or you succeeded in all of them in this time frame, or you get a compilation error sometimes, or you get memory exceeded. You can get different outputs from the judge. When I was competing in the beginning, you sent in the code to a human, and the human will compile it and try it with different arguments and so on.
Yeah. I mean, cool. And I guess it's rather different then, because you have a time limit as well that you can spend on it.
But normally you have it in a real project as well. From the client, you have a time limit, a deadline.
You do, but it's not that short, right?
No.
Or what's the normal time limit that you have in?
In a programming competition, it can be 1 hour a problem or something like that, even less sometimes. But 1 or 2 hours a problem. And the problems should be, if you know how to solve it, it should be solvable within maybe half an hour. But you need to know a lot about different data structure, algorithms and so on. And you can read it online, but it's also, even if you know I should use Dijkstra's algorithm here, or I should use the Simpsons algorithm here, you need to transform the problem and the data to fit the specific algorithm. So it's not only like you have this data, sort it fast as possible. It's a bit more tricky.
So what would be your tips if anyone is interested in getting into competitive programming? What should they do? Should they learn about like basic data structures, basic algorithms?
Yeah, that's maybe the second step. I think you can start working directly, just tinkering around. You don't need to know all our algorithms, or it's hard also to know what kind of algorithms should I know in the beginning. So start to solve the problems. Usually you can solve it in a naive way, and then it will find the answer in maybe 1 hour, 2 hours, 5 hours. But then you can start like search on different breadth first search or depth first search, or different sorting algorithms and so on, just to get the grasp of how to think about it.
Yeah, I mean, cool. And there was this new thing from DeepMind. What was the name of it again?
They are trying to solve these emo problems, math problems. Is it?
No, it was AlphaCode. It was actually a model similar to these large language models, but in this case, they actually tried to, given just the textual description, if I recall correctly, of the problem in programming competitions, write the program and have it, win this kind of competition. And it's kind of different. You have these kind of codecs and other models that can help you program and write code. But in this case, I think, if I don't remember incorrectly, it was AlphaCode, and they basically trained it specifically for competitive programming tasks. They took historical ones, they gave it the textual description, and they made it train how to do that. And
so they trained an AI to solve typical competitive programming problems.
And I think they didn't beat the expert human, but they came, I think, to the 50%. Or 50 percentile of like average human performance, so to speak. But still, it's kind of impressive, right?
Exactly. Yeah, it's really impressive, and it's much more. That is much more impressed than these GPT codecs. Right? You write, I want a button on this location. Yeah, it's quite easy to figure out how to have that button in that position, but it's much harder to know what kind of data structure and so on.
Yeah. Do you think, how long would it take until humans are succeeded by AI in competitive programming? Do you think it will?
Yeah, some day, some year it will happen. But I think it will take quite a long time until they are better than all humans, because it's the most challenging problem are really, really hard, even for the most experienced humans, and you then don't have so much data samples on the solutions. So it's hard to tell, but probably before the 30s, so within 8 years.
Awesome. Yeah, similar to what was the person that predicted that the singularity would happen in 2029? Kurzweil, thank you.
But this might not be the singularity.
No, of course. Yeah.
But it's coincides.
The timing is at least.
But if we go back to the university, what was the reasoning around choosing going down the physics path?
Yeah, it was because I am interested in physics, and I think physics is the foundation in many fields. So it's good to know a lot about physics, and also a lot of my role models are physicists and good.
Like who? Any specific person?
For example, Max Tegmark and other people as well. But also, I am interested in how the university works.
Yeah, and if I tweak the question a little bit, where was your career path? Or I'm not sure you were thinking, but physics.
I wanted to do robotics.
You were clear on robotics early on.
Since I was 10 years.
So
I wanted to do robotics.
Your direction was robotics, but instead of going the programming route to robotics, you find the physics route to it.
And you need to know about mechanics and you need electronics and you need that kind of stuff as well. And I already knew quite a lot about programming, so then it's good to learn more about how to create PCBs, how to create sensors and the hardware. I had already in high school and junior high school built robot myself, not only with Legos but also electronics with transistors, resistors and so on. So I have been doing that, but I wanted to learn more how to calculate what values should I have on this capacitor and so on. But
just to continue on this train of thought now, going into university, knowing I have a clear direction, I want to be in robotics. How should one think around your university curricula, or how did you think to find a path?
I thought that, and I still think, the most important thing is to do what you're thinking is fun. Follow your passion. If you're into software, follow that. If you are more interested in hardware, follow that. Or if you're into like the brain and cognitive science, read cognitive science program. I think all of these competences are needed when you are building a robot. So it's better to follow your interest, because then you will learn more and you will be a better.
I love that advice. You know I want to be in robotics, but this is multidisciplinary. So where is my passion and how does this fit robotics?
Exactly. And nice. I can also add on that I read international applied physics. So I have always been interested in languages as well, even though I don't speak so good English. But I read Spanish at the university, and I took 1 year off, or not off. I studied applied physics in Spain, like thermodynamics and quantum mechanics and so on in Spain. So that was also one reason I chose to read in Linköping and applied physics, because the computer science program don't have this international profile. Then of course you can go abroad, you can read in an English speaking university, but I wanted to continue learning more Spanish. And I still think that can be a good knowledge for my career, because a lot of companies are looking to the east, to China, Japan and so on, but you have the Southern America, Latin America.
It's huge as well.
Yes, and a lot of people, and quite cheap people that you can hire there. So if I'm going to build a good and big company, maybe we can have the production in Chile or Argentina, because I can speak Spanish.
Awesome. And I'm eager to speak more about quantum mechanics and your thoughts about that. But before we move into that kind of more philosophical topics, perhaps we should just take a small step back and say, I think a lot of people just confuse what AI and robotics is. If we were to start with just what is robotics, do you have a preferred definition of what robotics really is?
Of course.
Yes.
And I can start with saying that there exist multiple definitions on this. But my definition that I use to tell when I'm giving lectures is that the robot needs to react on the environment and act. So it could not only be a sensor that is reacting, you need an actuator, a motor, something that should happen. So for example, lawn mower, it reacts on the bumpers and moves away. That's a robot.
What about the chess playing machine that is playing completely in a virtualized environment? Would you consider that to be a robot?
Yes, you can have software robots as well. It doesn't need to be a physical artifact. And I would say also that these trade robots, they can be robots. They are reacting on the environment, taking decision and acting. Should I sell this? Should I buy this? Also chatbots. they react on what someone is talking and answering that. So I have a quite broad definition on
so it doesn't need to be mechanical. So
no, it can be a software immaterial, like only digital software.
But it's also a rather similar definition to reinforcement learning. It also basically says that anything that acts in an environment and actually performs some action and then use that to optimize some kind of future.
But there you had the difference that you have some form of experience. The behavior will change. A lawn mower will do the same. It will go into the same tree all over
There's no
again.
Learning in it.
Exactly.
Yeah. I like it.
So in your definition of robotics, you're not highlighting learning.
No, exactly. It's not AI. It's not learning. It's not machine learning. It's a physical or immaterial thing that will do things. Sometimes using AI, sometimes using rules, but it will do some form of production or some form of action there. And I can differ this from typical like industrial robot, because that robot usually now it's coming more and more robots with vision. But if you skip these modern vision controlled robots, they are only following a path, going from one point to another to a third one and repeating that all over again. Yeah. That's not a robot. It's just a machine following a path. So you need a sensor to react on the environment.
So that's another part of the definition, that the robot has a sensor in some ways.
Some form.
To differentiate it from a sophisticated machine.
Exactly.
I mean, I think that's a really good definition. I really like it. But I guess, I get a bit annoyed because people conflate the two terms. They think that robots is AI or AI is robotics.
All the times.
Right.
And also confuse it with these RPA systems. So when I'm out, they are always, you're working on the RPA field. And I said, no, I'm not doing screen clickers.
But now this is an interesting topic. Can we argue with the logic of definition of robotics that a screen clicker is robotics at all, a virtual robot?
If it's using...
Now we're going down a path he doesn't like. But let's
it's fine.
Is a screen clicker a robot?
If it's just following a pattern, like
then it's a
moving, then it's a machine. But if it's using some form of optical character reading or something like that, then you might define that as a sensor and it's using that as an input. But usually all the RPAs I have seen are stupid machines, because if the program change, if the layout of the software change, the software, the RPA needs to be changed.
And I should clarify as well, I'm not against RPA. What I'm against is that they think RPA is AI, or that they think it's the future of AI or something. It's just a conflation of what the terms mean that I'm against. RPA can be super useful.
I use them.
Yeah.
I program RPAs for myself.
Yeah.
But I don't think the naming is so good.
And the real problem, what upsets us, is that in this big hype train, where we start muddling the definitions, we are modeling the problems that can we solve with the different tech, and all of a sudden we get a LEML train. Now we should do everything with the RPA, which is a really, really bad idea. So by being a little bit more clear on the definitions and not overselling it, but showing what it's truly useful for, we would all benefit.
I think that the RPA have a use today, but in the future they are not necessary anymore. I was meeting the Minister of Digitalization here in Sweden last week, I think, and we was talking about just this, and he said that we are trying to, in all this procurement.
Procurement?
Upphandlingar.
Procurement.
Procurement. They should have a requirement on open APIs. So, for example, for the police or for the community or whatever, they should have an API, so different programs, different institutions can talk to each other using software instead, using a REST API, for example.
Exactly.
And then we don't need any RPAs.
Oh. Yeah, cool. I mean, it's actually similar to, if you remember Henrik Langren, he came here to speak about Arctic Capital. It's like an investment firm. But instead of you making pitches to what you should invest in, they simply look at the data and say, okay, this looks like a good investment. imagine if that was possible for procurement as well. To actually just say, okay, give me your data and show it, and we make a more objective decision on how to proceed. That would be really awesome.
Yeah.
Cool. And perhaps we haven't mentioned what RPA stands for. So it's robotic process automation, right?
Yeah, and it's a term that was coined by the vendors that is sort of building these types of systems to automate mundane office tasks.
For example, if you have a program for your invoices and you need to copy that to your bank or something like that, you have a software and you can copy the bank number and the amount, and then the program can paste it in the bank and send it over.
And we derogatory call it screen clickers, because simply what you in one way do, you record the macro of doing a manual task, and when you're recording it sort of follows what have you clicked on and what have you done, and then basically the automation is about playing that up at the right moment.
It's a macro.
That's all it is.
I guess we can use some other favorite terms of ours, digitization versus digitalization. And this is a clear example of digitization. You have the same process as you had before. You just try to
put the layer on top of it.
So it's the same process, you just try to digitize it.
And the core idea here is that we haven't really rethought the process with the support of data or or software. We have we have an analog process underneath still, but we have a screen clicker doing the analog job.
Should we, before we continue on your background, by the way, because you have so many different companies, etc., that would be nice to talk about. I know this is a rabbit hole that we can speak forever about, so let's try to keep this question really short if we can. But we spoke about, what is robotics? Now we have to go a bit
What is AI?
Yes, your favorite definition. What is AI?
So AI is about having an artificial, like the A is artificial, decision software. So something like a robot or just a computer vision algorithm or something that take decisions by itself. So I don't say, do that, do this, but the algorithm can do the decision by itself. And I have a quite broad definition here as well. So, for example, good old-fashioned AI, like rule-based AI, is still an AI, but then it's just following a lot of different if statements. Or you have a state machine that's also like a lot of if statements. And this is an AI. But then you have like machine learning and different kind of new neural networks and such, where we have this learning. So AI doesn't need to have the learning component. It's just the decision making that the software is doing. I'm not clicking, do this action, do that action, but the software itself will do it.
I really think this definition is refreshing, because if you do it to the broader sense, it's the decision making you're highlighting here, and you don't care how it's built up. I mean, like if you go down another part of the definition, I would argue that the learning of the ability, when we talk about artificial intelligence, now we switch more to the focus on the intelligence part of the AI, so to speak, and then we could argue. What is the definition of intelligence?
Yes.
We have our favorite ones.
Should we go there?
Yeah.
Or do you have a preferred definition? And we can give ours as well. But
I don't know if I have a preferred definition, but it is all about our perception if the system is intelligent or not. So I can see like animals, some animals seem more intelligent than I think they are more intelligent. Some robots seems more intelligent, like this Elsa robot is more intelligent than a lawn mower because it's jumping to the same tree all over again. It's still AI, it's using some rules, but it's not intelligent. So it's more about my opinions, or it's more about how I feel about it. But that's not a good definition.
No, I can give you mine, by the way, and it will be fun to hear what you think about it.
You stole it, by the way. Is it yours now?
My preferred. No, of course I stole it. And the first definition of AI in general is actually stolen from 1956. It's one of the original definition, I would say, which is that AI is the software or the science and engineering of building intelligent machines. I would say systems instead of machines.
Intelligent systems, and then all of a sudden you have the definition of intelligence.
Yes, so it comes directly to what intelligence is. And it's also very similar to what you said, because it's not really about learning, it's not a necessary component of it, it's just that it has to have some kind of form of intelligence. And then it's AI. It's just it's embedded in some system, software or hardware, doesn't matter, but it's some kind of system. So I think that can be easily accepted in some way. But then the really big question is, what is intelligence? And I actually changed my mind not that long ago, like 5 years ago or something. No, 3 years ago. And it actually was François Chollet's definition in 2019 that he started to speak about intelligence as a skill acquisition efficiency measure. So he basically said that if you have a system that can learn to play chess, but it can learn to play chess very, very quickly, efficiently, then it's intelligence. If you have a system that can learn to recognize images and see that it's a dog or a cat, but it can do that very efficiently, then it's intelligence. If it does it inefficiently by, for example, programming and hard coding all the rules that the chatbot has to have, then it's not really intelligent. It's just a system that through huge amount of work learns to do a complicated task, but that only brings it knowledge. It doesn't bring it intelligence.
No, so the distinction, and this is the distinction between intelligence and knowledge and learning. Knowledge, right?
Mainly intelligence and knowledge, but then learning is the way to obtain intelligence, right?
And how fast you learn is this then?
Yeah, and I would say actually you can obtain intelligence by manually programming. For example, Elsa. It's just it goes so slowly because you have to enter all the rules by yourself and change and adapt to every change that happens. So even though you can have some level of intelligence by hard coding rules, which good old-fashioned AI is about, it just goes so slowly. So that's why it's a low level of intelligence. But by learning from data and automating that part, so you learn the rules automatically, it goes so much more faster. Yes, it's more efficient, hence more intelligent.
But the interesting topic then becomes that we have artificial intelligence, and now we're then talking about the different, is it high artificial, is it high intelligence or low intelligence? I think
the more efficient you are in obtaining.
But do you have any metrics? Can you measure it somehow?
Yeah, time or memory wise, I think time or memory complexity is probably the easiest way to measure it. Do you like that definition, or what do you think about that?
Yeah, it's quite neat, but that's not the same as we use for humans. We are more into IQ and so on, measuring intelligence by having some tests you do and you normalize it over the population.
What are we measuring when we are measuring IQ?
Yeah,
really progressive metrics.
What is it really we're measuring, right? Because it's different types of problem solving.
Yeah, only one type of problem solving, matrices. Matrices. You see the patterns in the matrices, if or not. But that's more into my definition. You measure how you perceive the system, how you perceive the human. Is it intelligent or not? If I think it's intelligent, then it's more. But that's much harder to quantify than measuring the time.
But I really don't want to defend, the type of IQ measures that or tests that we have. But in some way, there's supposed to be some kind of test that is not possible to learn. So even though you try to learn by doing hundreds of them, it shouldn't improve that much. But it does, I would argue. You can train to be better at IQ tests. It's just it's rather hard. So in that way, it is more intelligent.
They have done
knowledge.
studies that you can hire your IQ with maybe 5 points. I don't remember, but you can't hire it with 30 points. Yeah. No. So you can improve it a bit, but not. You also have some form of born.
In that way, it is actually some kind of intelligence because it's not knowledge. It's the ability to learn how to solve a task in a short amount of time. So in that sense, it measures that.
And the interesting then, how do I devise a test that separates intelligence from knowledge? And that's what the IQ test is trying to do.
Yeah, it's also what Chollet tried to do with the ARC challenge and whatnot in his paper. I actually disagree quite a lot with Chollet and other points, but we shouldn't go there. I think, but we can take that to my point. Awesome. Now we have a really good, I think, definition of robotics and AI.
And you kind of like them, huh?
Yes, yeah, of course.
Because sometimes, I'm biting my tongue and I spill it out. But you're not biting your tongue. I don't see you biting your tongue.
Fredrik is a star.
Smart guy. Yeah.
Cool. We haven't even gotten into university studies, but okay. How did you chose to do studies in physics then, but you also start working with robotics rather quickly then?
Yeah, I was like doing this competition and I had this email, have you cheated, or how can you be so good in programming? And they actually did some searching online and found out that I have been competing in these programming challenges, but foremost they found out that I have been competing in Robocup even before I started university.
So you were recruited.
Yeah, exactly. They recruited me to start a new robotics lab under Fredrik Heinz, that is a professor nowadays. Yes. So I was recruited to decide, or together with the other researchers, what kind of robots should we have, what kind of computers, what kind of GPUs should we have, and so on. And we started up a small robotics lab at the university for humanoid robots like Elsa here.
And was this the start of the humanoid robotics lab?
Exactly. That was the start at Linköping University for the humanoid lab. So I was part of that and ordering all the equipment.
Oh, you had so much fun,
Yes.
buying toys.
Exactly. But also I was teaching robotics using the robots, and introductory course in robotics, and having the robots. In the beginning we just had 2 robots, and then they gotten more and more. And now we have 12 of them in the lab.
So in this way you were recruited into the lab
to start the lab.
With the real goal of winning Robocup, of course.
We should go really to Robocup, and I think and speak about how does that work, how do you compete, and how, everything. So but we have mentioned Elsa so many times, and I think I can see she's starting to be a bit bored here.
Yeah.
And I think we should really introduce Elsa as well, so she doesn't become too sad about not joining the discussion. Could you welcome Elsa to the discussion, please? Or?
Yeah, of course. So often when we are using robots, and as you said as well, you said that, Elsa looking bored, but the robot itself is not having any feelings. But we as humans are putting feelings
projecting
on robots. But we are using these kind of humanoid robots in research, like swarm behavior, different robots competing together, doing stuff, and also developing awareness of the environment, like computer vision, planning, navigation, and so on. And we have them in research projects, but also in competitions. For example, a world championship in soccer and Robocup. And then we have 5 against 5 on a small field. But
don't go into Robocup.
No,
I think we have a
sorry.
separate topic for that. Just welcome Elsa to the discussion, please, if you could.
So I can start her up using my computer.
Can you get her in the camera as well? Yeah.
So we have a small Python script, so I can control her. For example, stand up, and then the robot will stand up. And now the robot moves all joints, the arms, the legs, and so on, to become.
My battery will soon need charging.
In a standing position. Now she has waited too long, so the battery is maybe a bit low. Awesome. And I can also make her talk. So, for example, the robot can say,
"Hello, I am the robot. I am better than Anders."
This is a stupid robot. I can hear that.
You're really smart. I really like you, Elsa. You are really smart.
And we have used the robots.
My battery will soon be charging.
I know, Elsa. We have used the robots in different competition, but also in Sweden Got Talent. So maybe we can.
So was this a specific robot that was in the talent show?
Yes. This has been in the talent show, and I can make the robot dance, for example. And this is pre-programmed, so we have done the animation.
got to be brave. You gotta have the patience and believe you're gonna make it. Gotta hold on.
Dancing is good. That sells itself. Nu kommer droppet.
We should really bring her to the karaoke shows later and see if she can actually win. For once, I can actually win a karaoke show. But yeah, I think she would have a big chance of winning a karaoke show.
And then
But also, I think we should be clear here. This is a bit of a gimmick as well, right? And
Yeah, for now I control the robot, but it can be used for more advanced AI. Yes.
Can you just speak a bit about the hardware? What type of robot is this?
Yes.
How does she work?
We have 28 motors, 28 actuators, and all actuators have a positional sensor, a temperature sensor, current sensor, so we can measure the current flow. For example, when the robot is grasping something, the current will go up. We have ultrasonic sensors in the chest to measure distance. In the eyes, we have infrared sensors, so it can send commands for a computer or a projector or TV, for example. But it doesn't look through the eyes. It looks in the mouth with a camera and in the forehead. And since it's looking in the mouth, it can't speak there. So we have the speakers in the ears. So it speaks in the ears, look in the mouth, and have the microphone up in the head, 4 microphones, and I can triangulate my voice or sound. So if I'm speaking from this direction, it will reach the closest microphone before the other one, and it can turn the head towards me.
Right.
And a lot of different buttons. We have buttons on the hands, on the feet, we have bumpers, and some LEDs. And in the body we have gyroscope, accelerometer, and such sensors to measure the rotation if it's falling over or something like that.
The simple task of standing up, what does that require in terms of you're using several of the actuators, the
Yes.
gyroscope?
Yeah, exactly.
What is in play?
It's like you said, if I turn the robot down, it will figure out how to reach the standing position from this laying down, and I have the same
Battery will soon need charging.
I have the same code when it's on the belly or the back. It figures out how to move all the joints. So it's some.
But how much is pre-programmed set of rules, and how much is actually driven by sensor? It actually second by second taking new decisions.
Yeah, so we have some pre-programmed rules that it select between, like a state machine. So if it's on the back, it's first go to sitting position and then go up. If it's on the belly, then it's go to the sitting position and then up and so on. So we have different pre-programmed rules. But for example, when it's walking, then it's the dynamical adjusting all the time. So if I take the robot here and I will walk forward, it's adapting the gains and so on, how to
Battery will soon need charging.
move the feet.
And a position. I killed it.
Don't kill the robot, Henrik.
My battery will soon need charging.
So, but we can, of course, it's possible to program everything like in real time dynamically, but the processor is quite slow. It's an Intel 1 gigahertz processor. So when we are doing more deep neural networks and so on, we stream the data from the camera to a stationary computer and then send back commands for the robot.
And what are the examples where you're starting to apply more and more machine learning and AI with Elsa? What examples do we have?
For example, when we play soccer, how to detect the soccer ball, and
because that is completely, they need to adjust to the environment.
Exactly, and find their teammates and the opponents, how to play. And there we are using both neural networks, mainly for the computer vision part, but we have also like potential fields of where to stand, vector fields, where to go on the field, what is the optimal stage and so on. And we also adapt different strategies depending if we are meeting Germany, we know that Germany is better defenders, then we play certain rules. If we are meeting Japan, we have another set of rules that the robots are following.
Tactics, it's called.
Yeah.
Super cool.
I'm eager to just throw in another Elon Musk quote then, just to see how much you agree with that. And he speaks about the Tesla car as a robot in this case. And I think we compare it to Elsa as well as a robot. But for one thing, he says that Tesla cars needs to have perception. They need to use the cameras, mainly the cameras in that case, computer vision, to understand the surrounding environment, to see other cars, to other humans, and how it's placed itself in that environment. And then once they have that kind of, he called it vector space, basically a conversion from the raw pixel data that they receive into some kind of internal vector space that represents the world state, so to speak. And then from that state, he wants to take a set of actions, like basically to accelerate, to brake, or to turn, right? And he says basically that you can argue that could be some kind of reasoning that you want to do to come up with the best action to take at this point. And then you can start to ask, what is the most difficult problem? Is it the perception problem or the reasoning problem? And his answer is a bit, I think, interesting. He basically says that it's easily the perception problem that is the most hard one. And the reasoning is rather simple, because he compares it to, for example, GTA, the game Grand Theft Auto, which is completely in vector space already to start with. And then it's very simple to have a computer-driven car in GTA.
Yes.
And it can be driving around in a very complicated fashion. And it's no problem at all to have some reasoning, if you call it that, when it comes to how to...
I would agree, yeah. And we notice this a lot when we are doing robotics. Usually we start out doing simulations. And I was competing last weekend in a firefighting competition. So we build robots that we send in an apartment, and it should find a small fire and extinguish that fire. And we started doing this in the simulator, and it worked perfectly. And then we moved the same algorithm over to the robot, and it didn't work at all. And we have this all over again in every robot we are trying. And then in the simulator, we add noise. We have like real models of the sensor, real model of the motors, but still when we move it to a physical system, it doesn't work. It's a good way. I still advise people to use simulators because you can iterate a lot when you're developing the algorithm, but you need much time on the physical system. Otherwise it won't work. And this is because of friction, it's because of uncertainty, it's because of the nature is not ideal. And this is why I love robotics. I started doing some games in the computer, I did a car game, and that is boring because you don't have these uncertainties. I want something physical to move around because that's much more complex and therefore much more interesting.
I must, just on the Elon Musk topic, did you see his last TED talk just quite recently?
What was it about?
No, he bought Twitter. He's going to focus on humanoid robotics, and he basically says to
Optimus,
solve,
right?
and to solve self-driving car, you almost need to general AI to solve it. I mean, when the physical problem, in reality, if you really want to solve it, self-driving cars, you're getting very, very close to what he says.
And that's also the topic of embodiment. You can't do a robot closed in a can or something. It needs a body. It needs to interact with the environment, to grasp things, look at it. Otherwise, you can't get real intelligence.
But I think we should be careful here, because he didn't say general AI.
No,
nor did he say human level AI. I think he said real world AI, if I recall correctly. Yeah, and I think it's a big difference, and it's an important one.
I don't want to go into an argument on the core semantics, but the gist of the argument is that the AI becomes very sophisticated in order to really understand what it's doing.
It needs to operate in the real world. I think that's what
he's saying, and that's what he's saying is, we think we've solved it, but then we bump on the next complication. On the other hand, they are closer than ever. So he's not saying that it's that far away.
I think also we can say that we can have working and useful self-driving cars without having general AI.
Yeah, of course.
Yeah.
And that's why it's important to make a distinction between real-world AI.
And but then maybe listen to what he said the last time, because I think I'm not saying he's saying general AI, but
I'm kind of sure he said real world AI.
But the AI problem is, for self-driving cars, is quite huge in terms of many different aspects.
Yeah. But the hardest part is the perception there, because we need good information to feed into the reasoning. If you have trash in, you will get trash out.
So if you have sufficiently good perception, then you have a perception of the real world, and then it's rather easy to make a well-working AI.
Exactly, and then that is why they are doing like Atari games and a lot of StarCraft and so on, because it's much more easy, and we can focus on the reasoning more than the perception. And we have other researchers doing the perception. We are doing research in both fields, of course, but it's hard to do them at the same time. Then we have StarCraft for the reasoning, and we have perception for the...
Yeah, so basically if you go to the reasoning lab, they will work on those problems
in the software,
in software, like a StarCraft game.
Exactly.
I have to ask this question, and sorry, we'll never pass the... But anyway, Fredrik, is Elsa conscious?
No.
Why?
Because she is just following the software, and she doesn't... Depends, of course, how I program it. I think in the future we might have robots that have consciousness, but for today it's just like a tool following the rules, and she is aware of the environment but not conscious. She knows about the environment. She can see humans, she can see goal and opponents and so on, and that's awareness but not consciousness.
What's the difference in consciousness and awareness? Because I think this is a brilliant, good example, and to be clear here. But what is consciousness to be conscious and not aware? What's the difference?
It's a bit hard or tricky question. I would say that consciousness is about
The battery will soon need charging.
Shut it down. So.
It's conscious about the low battery
She's
level.
actually conscious about her battery level. I would argue. Is she aware?
So I would say that it's an understanding on the environment, understanding what is a human, what is opponent or goal and so on. But she is not aware. She is aware of the goal, but she doesn't understand what it is. The like semantics and ontology, and she can't connect it to other stuff in the world. Only in the game, she is very confined reasoning space there.
Yeah. Can you have confined consciousness?
If we try to just elaborate a bit further and say that, imagine you had a very confined space, very confined world. Perhaps it's only the world of playing chess. The only thing you can do is take an action of moving some kind of piece on the board. Nothing else exists. Then it's easy to say that the virtual software would be very aware, at least, of all the positions that you have and what actions to take. And you can sense what's happening in the game, and you can take actions on it. And you can reason about that and perceive what's happening. Is that still not consciousness, but in a very confined, like a narrow consciousness? Could you argue that there is such a thing?
Yeah, I could argue that consciousness is in different levels. You can be very high consciousness and low consciousness, and that's also between humans. If you have taken drugs, maybe you are in the lower spectrum, and so on. So yes, that's a spectra, and if it's in a confined space, vector space, or whatever you have there, or the only thing that exists is the chess game, then it's consciousness within that field.
I would actually say that, similar to what Elon said, real world AI is, perhaps we have real world consciousness. And today's consciousness or awareness that Elsa has is very narrow, of course. It doesn't understand what she can say that this is a glass potentially, but she doesn't really understand what the glass is. She doesn't have the background knowledge of that.
But that is also programmable. You can do an ontology about the glass and what you can use it for and so on.
But if we add now the latest and biggest large language models like GPT-3 or even greater ones, like Gopher or whatnot, that wouldn't, and basically you can ask them stuff and they can say something that they understand what the difference, understand is a sensitive term, but they at least have a larger understanding in at least what a glass is.
They can distinguish things.
Yes. And we get, not to human level, of course, but at least to a stronger level of understanding of what objects are. Would you agree with that as well?
Yeah.
So we can get closer to, it's not human level. Perhaps it's some kind of real world consciousness that Tesla cars have. But it's not human level, but it is useful level to at least.
But then it became hard to tell the difference between awareness.
Yes,
and conscious.
That's why
we are blurring the line of. I like the way we have started. That there is a difference between awareness and consciousness. That makes sense to me. Can you have consciousness without the conscience?
Well, at least to me, I don't want to go too deep in this, but at least for humans, we can very easily differentiate between unconscious and conscious type of actions that we take. At least that's one part of it, and we know that we can blink the eye without taking a conscious choice of doing so. But then the eye is potentially aware that something is happening here. It's not consciousness aware of it. So it's something about, I would argue, and please disagree, but it's something about the type 2 type of reasoning, this kind of thinking fast and slow, Kahneman's kind of thinking. So if you actually have huge amount of background knowledge, understand what things are, you have a good perception of the world, you have a world state, and then you have a type 2 reasoning system, then you get really close, I would argue, to consciousness. Would you?
Yeah, I agree in that as well.
Yeah. And Elsa doesn't have a type 2 system yet.
No. And let me
nor background.
Let me break the bubble, but I actually try to close this. Why is it important that we understand these differences and understanding on this? Why is it quite interesting?
When we are talking about these questions, we need to have common ground, so we know what we are talking about. And when we are talking with different researchers, you should also know that we are using the same understanding or the same definition of awareness. And
I argue there are many levels of usefulness by really getting clear on this. I mean, like, first of all, we have the fundamental of collaborating and working together and making sense of it. Then I argue it has a quite huge impact on the whole field of AI ethics and what is regulations and stuff like that. So we are regulating the right stuff, and we are understanding what it is we are regulating. It's a little bit like you said, we project feelings on her, right? This is scary stuff when people are projecting feelings, and then that turns into regulation. So I argue several topics, but then I think even bigger. If you want to solve more and more sophisticated AI, I think you need to really understand what are the components and capabilities that builds intelligence, or build consciousness. Ergo, you need to break it down into how do we define it, how do we work on it, if we want to progress in the field. So I think these fundamental questions become very important.
I mean, people dismiss them as some kind of philosophical topic that not worth even discussing.
But I think we need to have this in the education system as well. Exactly. More philosophy, more ethics, and so on. Both in high school, but also at the university for engineers to read at least one course in philosophy.
Yeah. Cool.
I just got a really good general question we take later when we come to singularity and all this. I have a question.
Okay. Keep it in mind, or should I write it down?
No. Keep it. I have it.
Fredrik, what is Robocup?
Robocup is an initiative from '98, I think, where we want to benchmark different universities, different algorithms against each other. And they was thinking about how should we benchmark it. What is a good rule book for benchmarking robots? And they was thinking about different, like robot wars and so on, but figure out that sports are very well known, and they have a clear rule book. And what is the best and biggest sport in the world? It's football. So then they started...
According to Swedes and European Brazilians.
It's the biggest sport in terms of utövare.
Yes.
What do you
participants.
call it? Participants. Participants.
And then they started Robocup 98 in soccer, and different size leagues, like small size league, middle size league, and we have also...
Software league, right?
Virtual league, simulation league as well. Sweden was part of that league in the early, what do you say, 2000s, yeah. And also we have humanoid leagues like...
that started in, was it 2005, 4 or something? Or when did the humanoid league start?
Yeah, in the beginning they had these dogs, Sony AIAW dog. But I think the humanoid is from 2004 or something like that.
I think so.
And then they have kid-size, team size.
2001, and there was no humanoid at that time, at least.
And are you playing with the same? So this is a SoftBank robot, right?
So there are a lot of different categories, and nowadays there are even more competitions than the soccer one. We have at home with service robots, we have rescue robots, we have a lot of different leagues, and both software like virtual, but also this Now robot, Elsa is a Now robot, is a standard platform league, so everyone has the same hardware, and that platform league has changed from the AIAW robot dog from Sony to this Now platform. I think in 2010 or 2011 or something like that it changed.
Is it a full-size humanoid league as well?
Yes, adult size.
And
then they build the robots from scratch by the teams, so it's both hardware and software development, and they the match there is 2 against 2, I think. One goalkeeper and one normal player, and they are so expensive. It's really expensive to build an adult size robot, so and they are so slow. You can look at them and they're trying to kick the ball, and it takes 5 minutes to kick a ball.
So which game do you think is the best to watch?
Middle-sized league I like. They are using wheels, and robots are really fast, like 20 kilometers an hour, and they are moving around, and it's quite big field as well, and they can shoot the ball and make it like in the air over other players and so on. So it's really interesting to see, and usually the winners in the middle-sized leagues meet humans, and they are getting better and better, closer and closer to the humans there.
The goal was to beat...
Exactly, in 2050 they should beat the human winners of FIFA. So the human players that win FIFA will meet the robots, and probably the robot will win.
I remember I saw the middle-sized league back in 2001 or something, and at that time they're probably much better today. But at that time, they had this kind of shovel wheels.
Yeah, they have still.
Okay, and but then they weren't really sophisticated, and they had a lot of rules. You're not allowed to like push other opponents or even co-players around. But sometimes have this shovel wheel rotating really quickly. If they, instead of the ball, hits another player, the player that flies out the field, and that was they got a warning or a red card or something, I guess, for that. But I hope the safety around these robots, if they play humans, is significantly.
And have you been successful? Have you competed, or is it every year? Or
every year it is, and they are actually changing the rules also to make the competition harder and harder and more like the human rules. So in the beginning it was on flat surface, and then they had some textile, and now they are more like a mat, so it's harder and harder for the robots to walk on it because it should be more human-like. And in the soccer we haven't been so successful, but I have also been participating in rescue, and in rescue I have been quite successful, at least in the junior. So they are both for university, and junior leagues are up to 19 years old. And in junior I have been on the second place in rescue, and then we are sending in a robot looking for victims after an earthquake, for example, searching and also delivering some water bottles and so on, medical kits for these victims in this building. And I have also been part of the at-home league where we have a service robot, and we have been quite successful in that as well. And we are using the Pepper robot from the same company as now. It's SoftBank Robotics, and the standard platform league, so everyone has the same hardware.
Awesome.
But it's so big. I mean,
it's a huge competition.
This is something that, if you're into it and if you experience it, it's huge, right? But
I think when I was in China, it was 4,000 robots.
Oh, really?
Oh, really?
That's amazing.
So really big.
Who would you say is the best in the world right now when it comes to Robocup? In terms of what continent, university, country, anyone that you can
depends. Australia is good in soccer and also in at home. Asian countries are good, but it's more like not the country itself, because you compete as your university. So Bremen in Germany is good.
Which Australian university are we talking about? ANU or Canberra?
Yes, the ANU are great, yes.
Yeah. I think Gutman highlighted that he went to ANU because of this.
Cool. And the time is flying away here. We have to, cover at least your background as well. So I thought, we can go through a bit of all the companies that you have right now and just quickly give some description of what you do there.
Yeah. So I worked at the university, and I got bored or not bored, but it was so slow. So I published some paper. I was at a conference, and it never came out in the wild to the general public. So then I started Dyno Robotics 4 years ago.
Yeah.
And Dyno Robotics tries to commercialize papers and algorithms and do products out of the research. And we are focusing in robotics in general, like navigation, planning, computer vision, natural language processing. So we have developed chatbots, physical, like this kind of robots. We are doing mainly software, but we have a workshop with welding, and we are doing PCBs as well, the hardware itself.
And could you give an example of a project or something that is in commercially we can buy from you, or projects you have sold?
We don't have any off-the-shelf solutions.
No.
We don't have you can buy this in our web shop, but we have done a dredging robot that is going under this lake and dredging the seabed. And we have done cleaning robot that can go in the parking lots, cleaning outdoor, like sweeping machine. And we are working together with many companies as a consultancy, helping companies with their innovation system and helping them test different proof of concepts.
What's the typical engagement? If it sounds like an awesome company, how should I engage, or what is it that I'm buying? Like, is it consulting a lot or supporting like ABB
No, not so much industrial robots. We are not doing robot integration for industrial robots. But for example, Siemens, we have done a telepresence robot, so they can use that robot. They send it for turbine, and the robot can go into the turbine and they control it remotely. And then we get the full project. So we are not like a normal consultancy hiring out a programmer.
You're trying to solve a solution.
Yeah, exactly.
Develop something proprietary for them.
Exactly. We are taking the full project in their innovation department, and we do it in our facilities. So we take it, we sit in our facilities with our workshop and programmers and solving a problem for them.
Fantastic. And sorry, last question. This is so cool. How much of this is typically software related, and how much is mechanical or physical?
We as the team are better in software, so we are looking more into software development. But we can do, and we have a farm of 3D printers. I don't know how many, maybe 20 3D printers, and we have like a workshop as well. But we are better in software development.
Yeah, but maybe if I reframe the question, these projects, even if you're doing it together with Siemens or something like that, is it always both mechanical or physical stuff and software?
We have done completely software project as well, where we are developing reinforced learning, for example, for Saab. And we have also bought some robot platforms. For example, these kind of humanoids, we can buy them and we develop software and then we sell it to the clients.
So you find a platform that is suitable for the problem, and
sometimes,
then you develop the software.
Sometimes, yes.
Awesome.
And sometimes we develop the hardware as well.
I get it.
So that's one of the companies, and then another company. I have had my own company, Fredrik Finurlig, since way back, and giving lectures and consultancy and so on. And in the pandemic, people asked me, "Can you give a lecture over Skype?" And I said, "Yes, of course, I can give a lecture over Skype. But you know that it's from 2003; it's 17 years old." And they said, "Oh, we thought that video meetings was the new cool thing here." And I said, no, let's go into the next phase. In the 20s, we are using virtual reality and the Metaverse. And they asked, what is Metaverse? And I said, let me demonstrate it. So I went up to Stockholm to their headquarters at that company and had some headsets with me. I didn't own my own headset, so I borrowed it from friends. And I was there and demonstrated how can we use it. And they said, this is mind-blowing. This is so cool. We need to do this. And then their event organizer they had hired for this conference said, we are out of here. We can't do this. It's too much technology. So then the full conference went into my my need to solve this. And I went back to my robotics company, Dyno Robotics, and said, we put the robot projects on hold and let us create a virtual conference here. So instead of CADing robot part, we was making a stage. We need everything you need in a conference. And the clients want balloons, they want roll-ups and everything. So we did that, and we organized the conference in April 2020, so in the beginning of the pandemic. And it was a huge success, and it was so fun to move around there. We had 300 participants in the VR environment, and CFO could have the economic presentation with a laser pointer and integrated to PowerPoint and everything, and communicating with each other. And one strong advantage here is that we can all be talking at the same time, and we can have two groups, one group standing in one place and another in another place, and they won't interfere with each other. In Teams or Zoom, we have one at a time talking. Of course, you can do breakout rooms, but here we have the spatial dimension, so you can move around. So when after the conference we have a mingle on a rooftop in a scene like Miami. So we was standing on a roof in Miami, and we heard all soaring. Everyone was talking around, and it was fantastic. And that conference was quite people was talking about it, and it got in the newspapers, and the TV, SVT was doing something about it. So after that, Ericsson called us, Saab called us, IKEA called us, and I thought that we can't continue doing this in the robotics company because we need to continue on with the robotics projects. So then we founded a new company called Around the Corner, where we was doing more and more conferences. We had maybe during the pandemic 60 conferences, some smaller but also some larger with several hundred people. But now it's the conferences are dropping, but we see more and more like selling showrooms. So instead of having a PowerPoint with your pitch, you can walk into the PowerPoint having your product in 3 dimensions. You can take your clients with you in there, and you don't need to use these VR Google's glasses. You can go into the web browser. You just send a link, and then you are in a virtual environment, and you can walk around together with the client and explaining your services and so on.
And how do you, maybe I'm jumping now, but this leads me straight into, is this Metaverse? Or what is Metaverse?
I would say that it's Metaverse. Metaverse is about social VR. You can be several, it's multi-user or multiplayer, environment, and you can display 3D objects, and you can interact with each other and the environment. So you can, for example, have a compliance guide, and you can do some quiz and training and so on. That's Metaverse. But then you can also say that Metaverse is connected to Bitcoin and connected to NFTs and that hype over there. But I think the main or the original idea is this virtual environment where you can move around.
This was my argument. So like the core definition of Metaverse is a social place in a virtual space.
I would say so, yes.
Something like this,
yes.
right? And then of course we have all these different tangents. You know, when you start going nuts of what how you could what you could do and how you could monetize it.
Instead of using bitcoins, we have done an integration to Swish, so we can do payments over Swish, and you can sign it and pay. And we have done that for Musikhjälpen, this Swedish program, national TV and radio. You can donate money over Swish and so on. So it's possible to connect it to the physical world.
So when did Bitcoin become a part of Metaverse? Because I don't know.
Blockchain, I guess.
Or blockchain, I should say.
Yeah, I think it has always been, or people are like the crypto guys are talking about it and want it to be part of some community.
Exactly.
And they found out.
I want to find a place.
Let's find a fluffy definition of something. Metaverse is a fluffy definition. Perhaps
that fits crypto.
Blockchain can be part of it as well.
Oh, shit.
Sorry, I'm dashing or ranting.
Bashing.
Yeah, we are also doing that. But that's around the corner, and we are doing more and more like showrooms and even studios. So we could have this pod from within Metaverse, and we have virtual cameras and so on, and then we can be wherever we want, and you can use it as a part of your like storytelling. I can snap my fingers and then we are in a new environment. So instead of just having your 2D PowerPoint, you can use the full environment to present your stuff.
And how do you see this? Why is this useful?
For example, it's easier to grasp a topic. If I'm talking about proteins, we had a huge conference for protein researchers. It's easier if we have the molecule or the protein or the virus in front of us, and we can discuss it and we can tear it apart instead of just showing in an animation. So it's easier to grasp complex topics. If I'm talking about math, I can have the plane and lines and intersections very visible, and it's more intuitive to have it in 3D. We are used to work in the 3D environment. We are 3D bodies, and then it's unnatural to work on the screen.
So in a way, if we stretch our imagination here, we are not in the future in the same way consuming something on a screen.
Exactly.
We are walking into the presentation as an experience.
I would say so, yes. And I think today it's quite unnatural to do the shopping on the screen or do all our interaction on phones or computer screens or TV. I think we will in maybe 10 or less years have more 3D content. With AR or VR, we can have more 3D content and also record. Today we are taking pictures in 2D. I think in the future we can take pictures and videos in 3 dimensions as well. So we can record information much higher dimension and much richer content.
How do you see the future of Facebook, now called Meta, playing out in this? I mean, Meta or previous Facebook has like halved in value now in last, I don't know, half a year or something.
But I don't think that's connected to the name change.
No, okay, agreed. But still, they are claiming, they've been popularizing at least the term Metaverse.
Yes, a lot. Yes, and I'm riding on the hype.
I guess so. What do you think about if we take Mark Zuckerberg or Meta in general? What do you think that will be the main like Metaverse going forward, or do you think that will
we have a lot of different competing platforms today, and the Facebook Meta platform is not so mature. We have better ones from Microsoft called AltSpace, for example. We have a lot of different startups, Spatial and Mozilla Foundation have also one called Hubs that is open source, and I think it's a very great one. We have another one called Frame VR. So there are competing metaverses, and they are not competing.
But I think this is very good to unpack, right? Because there's so extreme media circus, especially when Zuckerberg and Facebook is around, and all of a sudden he sort of for the non-initiated, Meta invented Metaverse, and that's the place to be.
The Metaverse, but it's not the Metaverse.
And would you even argue that it's not even the most mature in terms of sophistication, in terms of how you can experience it?
They are definitely not the most mature, but they are having a large team on it. So
when they put their money behind this,
exactly,
they will accelerate.
Might be, yeah. But it's hard to tell, and it's when the internet was new. You had a lot of different competing agencies working.
But I think this is the scary part, because internet to me is open source first, and no one can really own the internet, or no one can sort of, I don't know how you. For me, it becomes really strange when one company is trying to dominate what the space. Do you see? I see that as
on the internet. You have a lot of companies doing web pages, they are selling web pages.
Yeah.
They are not. No one is owning internet, but you have content providers to the internet.
And
you can say the same here. You have Microsoft as a content provider, or Facebook as a content provider, maybe.
But you do have, huge.
Yeah, you do, I guess.
Tech giants.
Yes, I just realized what I said was not correct.
Exactly.
I just realized that.
Especially in these days when some specific people are buying social medias, and dominating with a few number of people and companies in extreme how internet works today. And what do you think about that? Do you think it's
problematic?
Elon Musk, What do you think about Elon Musk buying Twitter?
He has good intentions, but I think it's hard to having open speech today, because you will get a lot of problems with racism and
harassments and
illegal content. So he has quite a hard job here to figure out where is the line. How hard should we moderate it or not?
But I must jump in. I can't bite. I'm not biting my tongue. No. But because if I'm super cynical, if you're in a position where you want to buy Twitter, of course, your rhetoric, why you do it, needs to be exactly what he says. But is that how do we know? Is that the real objective, or is it the complete opposite? To basically be able to have a platform for his, let's go all the way.
Malevolent intent?
I don't know, but ultimately, you have the ability of a propaganda machine.
Yeah, of course, but he has always been pro free speech, and he has always since the beginning talking about these values. So I think he has these values.
Okay, so then I think the problem is this. It becomes scary that who has the most money buys the propaganda machine. We are then in the hands of the ethics of the buyer. Yeah. And now here he can steer the ethics, right? And all of a sudden, okay, I really hope he is a benevolent dictator, right? I really
benevolent, right?
Benevolent. So
I don't hope it's malevolent.
Maybe that was my Freudian slip.
Exactly.
You don't put words in my mouth.
Good. Yeah. Okay.
But that's the problem, right? I mean, we can only hope that he has the right intentions.
Even before he bought it, it's people owning Twitter. So it's not like any...
No, it's not a change. It's not a change in mechanics.
It's in some sense, it's a change, because before it was a public trading company. They had to own to the stockholders and shareholders that they had. Now it's a single person that can literally decide, how it will evolve.
Yeah, and it's another dimension in it. It's like, if you have an owner who only does this, that's one dynamics. If you have an owner who does this, but the real empire is over here, it's a different dynamic in ownership, potentially.
I'm optimistic person. I hope this will be changed to the positive.
But it's really up to him.
It's dangerous that it's concentrating the power to even fewer people.
And we have seen it, right? Jeff Bezos bought Washington Post. So
good point.
A lot of these rich people are buying media houses or media platforms. And why?
Yeah, I mean, and here is a little bit like, I think we should see. I see Elon as he has the right intentions, but at the same time, let's not be naive. That's what I'm saying.
I mean, it's like democracy in general. Of course, I think we should fight for it. Certainly very important to me. But we know that democracy is not actually the perfect way to optimize a society. It's just the best way that we know that we have. And now it's actually turning the other way in terms of how social media is controlled. It's not going potentially. But of course, Elon Musk is arguing the opposite, saying, by providing open speech and free speech, it's actually improving democracy. So I choose to believe that's the case. It's a bit concerning that, power is concentrated to the few.
Yeah.
The problem is how to do it differently. Because we get to the same problem we're talking about. Oh, we need a European cloud provider to compete with and it's the same, right? There needs to be someone stepping up for free speech, or should you do it state, government-owned free speech, as a platform? I don't know if that's any better.
But you have this direct democracy or like that thing, and you can vote in every question, or you can have someone voting for you.
Like in Switzerland, almost at least.
Yeah.
Cool. Let's move to another topic if we can. And
more companies. You spoke. Is it those two are the two main companies?
I have 5. So actually I have mentioned 3. Fredrik Löfgren is for the lectures. So that was the one I was invited. As around the corner is the Metaverse company, Dyno Robotics robot company. I have also a company called Safe Reaction. We are doing sound analysis, AI for identification after a crime. We can see if someone has broken a glass window, or if someone is firing a gun. So identifying different kind of events.
We have an after work talk here coming up.
Yes.
Say no more.
Cool. So that's Safe Reaction, and then I also.
So basically, how would you describe what are they trying to do?
Identifying events, preventing crimes, or identifying when it have happened a crime. We can send alarm to the security guards or the police, and we can also, using this AI, identify. If we have a bicycle that has a special noise, we can have the fingerprint of that noise, and we can see the bike in a new part of the city. We can correlate that it should be the same.
Essentially, we have computer vision and we have CCT, and now what happens when you flip this story to sound?
Yeah, exactly. That's the same. But the CCTV cams can't see around corners. No. They can't see if it's dark. And usually, if you want to do a crime, you can look for the cameras and shoot these cameras
and you
first.
have the whole privacy, the whole computer vision regulatory
and
issue.
Also in a cam, it's hard. You can see someone is pointing with a gun, but you can't see when it's fired or if it's fired. You can just see that someone is holding it. But in a sound, it's really easy to identify. Now we have a shot.
And when it was.
Exactly. And in dark and so on, we have problems seeing. And with sound, we can also triangulate where it came from.
Cool. Any more companies? I think it's enough.
I think the last one, if I
can you just mention perhaps a bit more about Genikampen also? I mean, you were part of that and won that as well. How did that work?
So it was a program. I thought it was more about solving hard math problems. when I searched for it, I was part of the first season, so it was impossible to know what I was going to do in the program. But in the first episode, we was up in an aircraft and we should jump parachuting down the earth and looking for numbers and mysteries on big fields.
So fun.
It was really, really fun, but it was not what I was expecting to do. So it was like a combination. If you know Mästarnas mästare with Micke Leijnegard was the host of both these shows. So it was a bit physical as well. We was running around and trying to solve problems, but also a lot general knowledge about history, about different Swedish kings and
So
music.
ultimately, it's a television show. You are solving problems.
Yes.
And it's a show. It's a game show or whatever you want to call it. Where in the end someone wins.
Yes. So different episode, and each episode someone is eliminated. Yes, in the evening duel. Yes, and you need to solve different problems in the duel, like EQ puzzles and so on. And it was so broad, so it was not only science or about math and programming. It was also about music and history and geographical knowledge. We had one competition, we had a blank map, and we should paint all countries and find out where is Malaysia and where is Kathmandu and so on. Point it out on the map as good as possible.
Oh, really general knowledge.
Exactly. And also some physical competitions, like we should build a trebuchet, like a catapult, and shoot bowling balls up on...
So mechanics, right?
Yes, mechanics. And carpentry to build it.
Carpentry, that's right.
So it was broad and very, very fun. And
how long did it take to shoot the show?
I think we was there 3 weeks or maybe 1 month. So it was quite intense. We had competitions every day and recording every day, and a lot of interviews, like these syncs they do, and then they cut out small parts. So maybe they record 2 hours interviews each day, and they cut out.
Where was it? Where were you? Where did they stash you, so to speak?
Outside of Nyköping, at a military airplane field.
You've been part of so many awesome events.
So fun, man.
I have to at least add one. We're not going to go through all of them, but it would be fun to speak about the TV4. No, but let's not go there. Let's take another one on SVT that I thought was both interesting but also concerning to some extent. And I'm talking about the AI debate, or as you say in Swedish, Mötet.
Yes.
And you debated against a more like AI robotics skeptic, I would call him. And I think, this type of setup that they have in this show is problematic to start with. But perhaps you can just describe a bit more. What was Mötet? How did it get started? What were you planning to do?
The program idea is to find controversies, or you should be really against something or really for something, and then you should debate it. And I think it's quite good as well. You might think it's a bad idea about the show, but then it's clear about the argument. It's really clear about what is against it, what can you argue for it, and what can you argue against it. So it's a good TV program if you want to learn the arguments.
I can buy that partly. But okay. I mean, can you really have an objective discussion in that show?
Depends on the subject. Regarding AI, yes. Regarding if Frölunda should change their logotype, maybe no.
But what's your concern, Anders, here?
I can get into that, but perhaps we should just describe a bit more what happened at that point.
I was there, and we was firstly filming some background. I was in my lab, working with robots. My opponent, if I am allowed to say so, was out in the forest doing meditation. So there we started the contrast.
They start building the contrast.
Exactly.
They're positioning you.
Between the natural human in the forest and the nerd in the lab.
They really pigeonhole you both, of course.
Exactly. And then we met for the first time with the cams on. So we haven't had any time talking before. We even didn't know each other beforehand. And we met with the cameras on, and we started to discuss. And the TV was also like, we don't have any moderator or host of the show, so it's only me and him talking back and forth. And then
But you have a manuscript or something, or
not really, but we had some questions. Yeah, we wrote questions for each other beforehand. So I wrote some questions for him, and he wrote questions for me, or quotations. Maybe you have said this. What do you think about it? Or why did you say this? So it's a lot of quotation they have found online and so on that I have said. Like, for example, I have in one of my lectures said we might have a prime minister that is a robot in the future. And then he was shaking his head and saying that this is impossible and this is bad and we should never ever have a politician that is a robot. And then I need to argue, yes, maybe we can have it because it will not be any what do you say, mutor?
Bribes and you can't influence them.
Exactly. So it's more objective and not so much feelings in the decisions and so on. And we continue like this back and forth, and he was more and more upset, and he was always restating himself, or you are a behaviorist, you are just judging the robots from their behaviors and so on. And in the end, he was more screaming like, "You are a fascist, and you should not."
Absurd. This is almost like he should get. You could file a lawsuit, I think, to him. The way he acted, actually. But
it was a long discussion here. I think we was discussing this 2 hours or 3 hours, and
then they cut the good pieces out for television.
make it 1/4 or something like that. But the reason he said so was that I said that robots can be smarter than humans. Robots can out-intelligence humans, and that was fascism, because you shouldn't say that someone is smarter than someone else. And you shouldn't divide people in groups or robots and humans.
What is problematic with this argument, when I listen to it, is that there's so fundamentally different understanding and knowledge of the concepts. So you're actually not talking about the same stuff.
Exactly. And he isn't here to defend himself.
No.
But it was a bit absurd, and he was also saying that I was breaking the international laws and a lot of things. And I was asking, is it only me? And he said, no, the whole field of AI researchers and the whole field are like betraying the humanity.
Yeah. Since he is not here, we shouldn't mention his name, I don't think, in his sake. But I think it's really problematic when you set up a discussion to be a controversy to start with. It's like these kind of you have this kind of straw manning versus steel manning argumentation techniques, and straw manning, this kind of idea that you just say the how should you phrase it, some kind of the worst part of the other person's argumentation. You just focus on that in a potentially not very objective way, and you don't do it in objectively giving pros and cons, etc. You just focus on one part of it and keep bashing, and there is I would argue, no way that you could ever come to some kind of knowledge, objective truth, consensus, or useful.
That is not the purpose of the show.
I know. But that's the bad thing. That's what I think is bad.
But you're so typical Swedish. Why should we reach consensus in every?
No, but you should at least strive for it.
Oh, good one, Fredrik.
You don't need to.
Nice.
If you don't want to, that's fine. But at least you should strive for it. I think if you strive for finding disagreement, it's so easy to do. I mean, it's like the if you want to complain or find destructive versus constructive type of argumentation. Destructive is 10 times easier.
My goal of being part of the show was not to convince him. That was not my goal, but my goal was to convince the audience that I was right.
I think it's awesome that you did it.
Yeah, but
I'm more annoyed with the format. the way.
But I think it's a good show still. Even though I was called a racist and so on, I think it's good for the audience to see the opponent's arguments, and then they can make their own decisions. So it's more about reaching consensus with the audience than him.
Maybe. I still think people that are not willing to engage in a constructive discussion should not be promoted to these kind of platforms.
Yeah, but the bottom line was the format is different. The format is antagonism in this way.
Yes, of course.
Yeah. And then you can argue, is that good or bad? And you highlighted, well,
to look at the extremes. Sometimes the polarizing views helps us see
to understand
the full picture, right? Polarizing views actually broadens your view from. So you're not only here. Okay, this
and
is the real.
they asked me to be extreme. They asked me to talk more extreme.
And that's the problem in some sense. But I mean, it makes good television, yes. And of course, that's what their point was. But from a more scientific point of view.
Yeah, of course, but that's completely different.
It is.
Yeah,
but just making good television, I don't know. That's my. This is my.
But I follow your argument when you say the polarizing views broadens the whole horizon that for the viewer to really understand how how big is this. But from any constructive.
If you want to learn something.
If you want to learn something or constructively move something forward, no.
I mean, it's very similar to what's happening right now on Twitter about the discussion between, I would say, Jan LeCun and Gary Marcus, you know, the deep learning versus symbolic AI kind of discussion. And they are so polarized right now that the only thing, you know, Gary Marcus is doing, and I'm a bit extreme, but he's strawmanning Jan LeCun. And Jan LeCun is doing the same. You know, Jan LeCun, who is supposed to be one of the foremost scientists in the world, wrote a tweet that I think is very questionable, saying, put up or shut up. Basically saying, you know, you can argue all you want for symbolic AI, but unless you can actually show something that works, then don't even speak about it. Put up or shut up. I mean, you shouldn't speak like that. I don't think it's good. It's not really helping you to come up with constructive arguments. This kind of, you know, polarizing discussions, I think is a bit dangerous. And, you know, I think if you instead have this kind of steel manning arguments where you have to think, okay, if I were to do the best that I can to think myself into the position of the opponent and make the best argument I can for my opponent and then do vice versa, normally that is so much more constructive.
Yes.
This is
Interesting.
Philosophical kind of thing.
If I'm quite often part of these panels, after my lecture, I'm invited to be part of the panel, and it's so boring to listen if everyone is saying, yes, I agree, and sitting there nodding together and feeling so great together. Then it's much better if we have one skeptical and one positive, and then they can have a discussion. And it's also like I can change my mind just to have more discussion, because it's a better.
I usually do the same.
Yeah,
actually.
exactly. Then you're on my side here. It's better discussion if you're arguing.
Not if you're arguing, but if someone is not demonstrating both sides of a coin, you have to take the other side of the coin, even though you don't believe fully in it.
So maybe you're doing that now.
Yes, I am.
He is actually.
But actually, I am doing that. If I were, or I am in some kind of panel, I can see the discussion is so one-sided here. I can easily take the other side.
Yes,
even
because
though
you know the arguments.
Yeah, but also because of discussion. Because I don't think the discussion is going well, as you said, because it's just everyone is agreeing.
So then you are on my side, that we should have polarized discussions.
No, we should have objective discussion. I do not agree. No. Okay, so the difference is that if we have a one-sided discussion, that's bad. If you have a polarizing discussion, that's bad. What you want to have is a double-sided constructive discussion. That is what I'm striving for. If I see it's being too polarized because of straw manning, then I want to argue against that. If I see it's being one-sided because everyone is agreeing, then I take the other side, but in a constructive way. So, okay, this is a rant.
So this is a rant now, but it's good. It's a good rant.
Objective, constructive discussions, I think, is very important. If it's subjective, one-sided, you do something, take the other side. If it's destructive, just polarizing, then you try to steel man or do something about that.
So let me try to alleviate the discussion. Why is this important? Why is it important that we have good discussions and that this is happening?
Because you want to strive for knowledge.
Bottom line, two-sided views, objectivity, the full spectrum is needed to gain real knowledge, to gain closer to the truth. And actually to build a balanced point of view. And why do we need that? We need that for regulation again. We need that for coming up with the best solutions.
I mean, the definition of science is basically to build knowledge, in my view. And if you want to build knowledge and believe in science, then this is what you should strive for.
And therefore, how we debate, how we discuss, how we act in these, and how we take different positions to help the knowledge building for the greater good. That's what we're talking about here.
Fredrik, you also participate even these years, to help young kids learn math, etc. Can you give an example of what do you do to do that?
For example, next week I will give a lecture about AI for kids aged 7 to 10 or something like that.
Wow, that's an interesting one.
Yeah, and I have also been out in kindergarten talking about AI. So it's like the younger they are, desto more interesting it is, because I need to adapt how I explain AI and neural networks and so on. So it's quite interesting challenge for me as well. But I think it's important because I was there when I was young. I have no one to ask about math or programming. My parents didn't know about programming. So I was searching alone on Alta Vista or something like that, trying to figure out it myself. Or
Alta Vista, you were like 7 years old then?
Yes. And I had internet on Fridays evenings, trying to figure out C++.
But how important is it that we have these role models for we can talk about children, we can talk about
I think it's important,
girls and boys and all that.
I think more important is that the children have someone to ask about these topics. Role models are of course very important. I think especially for girls, because we need more girls into technical field, IT field, and then role models are important. Me as a boy, I can find my role models already, but I need to have someone to ask my questions about black holes, about the universe, about math, integration and so on.
But let me, and why do we want to raise curiosity, or asking question, have someone to ask? I think it has a connection to curiosity. Curiosity leads down to people expanding their minds of what they could do or what they're passionate about,
and they can solve new problems and see the world in new ways and figure out new solutions on the climate crisis, on the AI problems and so on. So that's something that we want to evolve the humanity. We want to be the next generation should be more clever and more gain more knowledge than our generation.
And are we better at this in 2022?
I think so, yes. I think we are getting better and better on that. And also with the internet and YouTube and tutorials and so on, you can learn much easier today than 20 years ago.
That is...
So that's evolving.
But I also argue I mean, like I look at my children, so I fully agree with you. The information is there. It has never been easier to learn. But at the other side, I think to some degree, when I look at my children, I think they're even more narrow-minded in what their interests are and what they're doing compared to when I was a kid, because we were playing games and on computer games. Now we were out in the building, physically, bygga koja. So I see the children is in one way they have all the opportunities to learn and do all these things, but at the same time I see they're getting more and more iPadified or whatever we want to call it.
I love it.
You see what I mean? So
I understand.
This is the craziness of it all.
And then I think these camps I organize are great, because there they can get hands on an Arduino or robots or whatever, and they try it. And if they are trying, like doing a robot, they might get more interested in that and then continue on in their free time. Yeah. So I think if I have never been a gamer. I have never found interest in playing games. I think it's much more interesting to do games than play games. And I think if we can open that for more children, that it's actually like creating a game is a more challenging game than playing it. It's more interesting challenge there. Then people can do that in their free time. But they need... tålamod. They need patience. They won't get this kick in the fast way as if they are playing an iPad game, but the kick will be so much bigger when they succeed.
Yeah.
So they need patience to get these big kicks to get the stimuli to continue on there.
I guess the question, and this trying to move into your question that you added in the beginning as well. So I'm trying to move into that and connecting the dots here. So in short, I'm very similar to you. I think it's so fun to simply build stuff, to engineer stuff, to have something that actually works, and the kick you get out of that is so extreme. And I guess in short, what you want to do is promote innovation in some way. And if you start to do that early on, as you're helping very well, to just build interest in math and engineering and tech, that is building up the preconditions, so to speak, for people to be truly innovative when they wake up.
You need to expose people to the innovation and what this is all about in order for them to sow a seed.
Exactly.
But continue.
So, and the question basically is, I guess you're very pro to having a higher degree of innovation coming up in the future generations that we see.
I hope so, yeah.
And I guess this is a very leading question, but still, how should we do that? I guess one way is to simply to build the interest early on. And is that the right way to do it? Or how can we simply try to improve innovation in coming generations?
Yeah, I think we should encourage it more in school as well, not just following the books, but to do subjects more integrated together, try to have the science and textile and carpentry, träslöjd together to do projects, more project-based learning, and also competitions. I think competitions are nice. We have always in the history liked to compete in sports and so on. I think we can have competitions there exist competitions like we have in Sweden Innovate, and we have Blixtlåset and different competitions. UF is also Ung Företagsamhet. One not really compete. Yeah, you compete in entrepreneurship. You have different prizes and so on. To have these as fundamentals in the school, I think is important. But Sweden are also already today quite good in innovation with the school system and so on. We are lacking behind in math and science and so on, but innovation we are quite okay.
But can I steal the question now a little bit? Because let's put a couple of minutes down the rabbit hole of innovation, and how important is it for us as a society and for companies to innovate?
I think it's really important, because if you don't, you will not exist in the future. So, and also we see that the majority of the employees in Sweden works in SMEs, small companies, middle-sized companies, not in Volvo, not in IKEA. So we need these small companies, and they are usually, of course you have some pizzerias and so on, but they are usually based on one form of innovation. So there we need to be strong, to have the labor market in Sweden. And especially when robots are taking more and more of our works and jobs and so on, we need more innovation to find new positions.
And let me continue. So we need innovation in order to
create jobs.
Create jobs and not become obsolete as a society. Now, do we all, how will we as a society, or most people, come in touch with innovation? And let me have an argument, and we can try it. I argue that the main thing for us as a society and is to one degree to innovate, yes, but I argue that with the technology advancements and all there is out there, we don't really have an innovation problem. We have an adaptation problem, or to adapt or relearn, or how should I argue? Invention versus understanding, this is something, this is AI, but how can I adapt this technology
to my needs?
Yes. And this to me now is that innovation or adaptation?
It's more adaptation, but you of course need both components here. Yes. And we can all see for example, when the smartphone came 2008 or something, it was not so long since, but today everyone is using the smartphone, and it was just 1 or 2 years until everyone was using the smartphone.
It's super fast.
Yeah, the adaptation was faster, and also when some new software and some, especially for the young kids, a new game come out, Pokemon Go, it was all over in 1 month. So the adaptation there is really fast, and also with social media and so on. And so I think we have it, but we also have we are like, what do you say, vanedjur, habit animals.
Yeah.
It's hard to change, especially I think when you are older, it's even harder. You're used to do something in one way. Why should you change? So I think this,
and then you lead me down to the third trait. So we have talked about innovation, adaptation, and then all of a sudden, as a society, we stand in a society where the rate of innovation is increasing, innovation pressure is increasing. Therefore, we can't build more and more efficiency the old way. We need to reinvent what we're doing, and this ergo leads to we all need to be really good at relearning, constantly relearn, and the dogma how we used to do things. We need to always be good at questioning that.
That is something that is very important in today, and even more in the future. We are talking about changing like career path in the middle of your 40s or middle of your 50s or something like that, and that I think is very important. That you need to adapt your career, your knowledge, and maybe today we are going in school 20 years or 15 years, and then we work for 40 years. But in the future, I think we might go in school 10 years and then start work 10 years and then go back to school. So we switch between education, work, and back to education. I think that's more and more important, and we see that we have yrkeshögskolor, and we are trying to educate our population in different careers later on.
Okay, so and now let me arrive at the final problem here. So we have talked about we need to innovate, we need to adapt, and ultimately we as individual needs to relearn. Okay, and this is vital, right? Now, is it any different for our enterprises or organizations to be able to innovate, adapt, and relearn?
No, the enterprises doesn't exist without employees. The humans are driving the employees as well. So if the humans are relearning, the enterprise will relearn. Yeah. And it's not like a magical enterprise, like it's not an animal. It's the humans that are like the boss and the hierarchy and so on.
I disagree. I think the organism of an enterprise lives according to some sort of ideology, of how do we run companies, economics, macroeconomics, supply and demand, economies of scale.
But it's still people.
But it's constructs of that was formed 70 years ago that is driving efficiency and cost reduction and a view of what is the way to organize, when it's a completely different way of organizing. If learning and relearning and we are focusing on perfecting a stable process. That's what we're good at, and now we need to be good at changing, reinventing process.
We see like big companies. Every time I call, I won't say any name here, but every time I call a big company, they are saying, "Oh, please, we are reorganizing our structure now. We are quite busy in this restructure of the organization. We can talk next month or next year or something." Every year they are reorganizing the company.
I think Spotify, it was like 3 times a year.
So it's like you say, we are perfecting the organization and it's stable there, but they are trying new types of hierarchies.
But are they changing ideology? I think they are not. I think most companies are not.
I agree with both of you in some extent. It's easy to say that you are doing a reorganization, but in reality it's just on the surface. It's not really changing the direction of the company. If you make a big change, this is example of what Spotify did in 2011, for example. They went from being a desktop first to a more of a mobile first company, because they realized that mobile phones is actually what they use primarily as a device.
But then it's more about changing business model.
In one part of it, and that's one big part of it, they have to change the business model, but they also have to change their product. They have to change the organization, what type of groups they have and how they were organized internally. And in short, they have to change the whole company to make this big transition from one type of business model that they had to another. So these type of big transitions is very rare, I would argue, and really hard to company to do.
Of course.
But with innovation pressure increasing, and now go nerdy on Ray Kurzweil's law on accelerating returns, I've been trying to really wrap my head around this, and this is a different ball game when you have an exponential. Yeah. We don't have a linear technology advancement. We have an exponential technology advancement. That's why we have that he says 2029 for.
But I also think that new companies have other ways of structuring it, more agile ways of working instead of IBM or some old companies. And then maybe IBM can buy these innovative companies and try to learn from them. Or these new companies will become bigger, like Facebook.
I think the latter argument, it goes back to Google or someone. You always say that we are not afraid of the big competitive giants.
The enterprises.
We are afraid of the new ones that really they figure it out. And but what that really tells you, that argument tells you when you erect the structure.
It's hard to change.
It's very hard to change.
Even impossible.
Even impossible, maybe, right? And then it goes all the way down to, well, we have companies now that are beautiful, fantastic companies that was erected 100 years ago. So this is the challenge, right, of relearning, right?
Yeah.
Fundamentally, business model, how we reinvent every single process.
Let me switch to a similar but different question.
Yeah.
And I think one that you have been speaking about before, Fredrik, as well. And that's the future of the job market, especially as robots like Elsa get increasingly conscious, perhaps, or at least get increasingly useful, if we say that. It doesn't have to be conscious, I guess. What do you think will happen in the future job market in like 10 years? Do you think AI and robotics will change that in some ways, positive or negative? What's your general thinking?
Yeah, definitely it will affect.
Yes.
Then the hard question is how, and I think a lot of jobs will disappear, but of course a lot of jobs will also appear. That we will have more engineers and more maybe cognitive science people, or more titles and occupation that we can't imagine today. So it's hard to list all new jobs that will appear, but a lot will appear. But I think the main problem here is that we will have a negative netto. We will lose more jobs than we will create. And that's something that I'm a bit worried about.
Both in long term or short, mainly short term or mainly long term? With the negative,
mainly long term, and we have seen that in the past as well. That we had in the beginning of the 90s, we had or maybe 40s or something like that. 60 hours a week we worked, and then 50 hours, and now we are 40. So that's the trend. We are working less and less, and we're getting paid more and more. So in the future, we might work 20 hours a week or something like that. And then we can have the same salary, and we can be more with our family. We also, I think this can be good. Many people see and are afraid of losing jobs, but I think we are so stressful today, and we are apart from our family so much. So I think if we can work less with the same amount of payment, then it's good. But the problem is if a few people work and get the payment, and
no one, other people is not part of the society.
Part of the labor market. They are part of the society. But
good, better framed. Thank you.
Yes. Then we have more segregation and more problems, economical segregation, but also other problems in the society. So that's one big challenge I see.
Yeah, I guess some jobs it's easy to see that they will be affected more than others. And if you take like truck drivers, which is I think the biggest job occupation to have in US. I think a third of all the jobs that they have in US is like truck drivers or something.
Exactly.
So you can see something happening to some of them. I would still hope, from an optimistic point of view, that more jobs will occur, but perhaps it will be a different type of jobs that actually is more suitable for humans.
If you're looking into the future, long term, general artificial intelligence, why should we work if we have someone or something that is equal or even better than us? Then the jobs will disappear. Or do you think even at that time we will see more jobs?
I think so, actually. Not more jobs. No. So the trend is, I think, clear, as you say as well. But that we will have jobs.
Yes, some people can have jobs, and we can see handcraft, like you value a painting painted by a human more than a paint by a robot.
Because I think this is interesting, right? Because when society changes like that, and we have more time, and we are more differentiating what is the human excelling at and what are we valuing. I mean, like, I can fully embrace the trend of we want to have handcrafted things.
Exactly.
We want to have more music.
And we
want to have more culture.
We can do music and culture for free because we will get paid by the robots. The robot will making the economy work, so we can have food on the table.
Yeah. So but then you can argue that I think somewhere in the way our ideology, in the way we work as humans, we want to feel useful. So we want to go to work. But maybe
you can feel useful if you are in the like NGO sector as well.
No. So what I'm saying is that we will. That's what I'm a little bit thinking, that we as a species, we will create jobs. We will synthetically create jobs, even if it's just for pleasure, like culture or for music or humanities or whatever.
So it depends on what you are saying about jobs. I think we will still have something to do. We will not sit in the sofa looking straight forward.
That's my point.
Yes.
But we don't need to have this for getting a salary. Yeah. We can do it for fun. We can do music for fun. So if you are saying that is a job, then we will of course create jobs in the future.
Occupation, or at least.
Yeah, I think the notion of occupation and belonging to a discipline and all this. I think that is not.
I think one way to phrase it is we have actually we have never had better social welfare than we have today. I mean, it is, if you do nothing, or you will still be able to survive. You will have roof on top of your head. You will get food, etc. That will just continue to increase in that sense, and that's a really good thing, right? I'm trying to end off here on a positive note. So in that sense, I think that kind of welfare will just continue to increase with the help of increased, taking advantage of technology, of data and AI, of robotics, etc. I think Elon Musk phrased it as we will have a future of extreme abundance.
Yes, I heard exactly this quote.
Right,
there will be an abundance of that. So
everything.
So it's a different it's a different mindset that's very hard to imagine.
And I think we have actually a large amount of abundance already today. If you just compare it 50 years back. I think that abundance will just increase in an exponential scale, according to Kurzweil.
And of course, the real problem is, can we distribute this abundance in a fair and equal way? Yeah. I think that's going to be the big problem.
To avoid this...
because the when you have an uneven distribution of power or an uneven distribution of, I would go, fundamental, satisfying, that will be the problem.
Exactly.
And also, just to try to end off here on a positive note, this is also the equality of finding use for an AI. Sometimes people think if you're not a data scientist, you will not have the success as data scientists have. So it will be increasing in quality in who can benefit of the future of AI. I think that is very, very wrong. And I can compare it to, if I give an example of my mom, for example. She worked as a nurse. She was horrified when they digitalized the journal system, They went from writing pen and paper into some kind of computerized form, digitalized form, and it was extremely complicated. You couldn't change anything. It was very hard, horrible user interface. It was very, very complicated, and it really increased the digital divide, the original term of the divide, in an extreme. And it was a very bad experience. And it's very easy to understand that people think that this type of technology, that AI is very complicated, therefore the digital divide will increase. And only a few very technically knowledgeable people will have the power to use it. And that is the strongest and worst misconception you can have, I would argue. What I instead say is the AI will actually make it much more human. Like with Elsa, you can speak to her. She can look at you. You can use the human type of sensors and actuators. And in that way, it will actually decrease the digital divide and make it super simple for anyone without even technical skills to take advantage of technology. Would you agree with that?
Yeah, of course. We are not made for using buttons and screens and so on. We are made for talking. That's the main communication interface with humans. Yeah. So with more voice controlled systems and more robots are also similar to us with the shape then it's more easy for us to communicate and interface with the technology.
Just to take a car. I mean, the car of today works in some way. The car of the future will be you walk into it and you say, please take me there.
Yeah, exactly. But much easier.
But the misconception here is about how many will truly design AIs and program AIs, and how many will use AIs in all types of forms and shapes and jobs. So that we all need to be data scientists. Well, that would argue that we all should build AIs, and that's not the case.
But you can train the system. You just like you raise children today, you can raise the AI to help you.
And you will be able to do that even because that process has been AI-ified.
Exactly.
Yeah. Simplified or...
So what do you think, Fredrik? Is the future in 10 plus years positive or negative?
Positive, of course. I am very optimistic about the future, but we need to be aware of the problems to solve them.
What will Elsa's children look like? How will they be able to behave in 10 years?
I think they will be very smart and maybe do stuff that we think is boring, maybe cook the food in the weekdays. We can still do the cooking on Sundays for fun, but when we are stressed, we're coming home, we have children screaming they need food, then the robot have already prepared the food for us and help us with a lot of everyday problems. And it can also be like we have a dog, we need to walk the dog every day, but it's not so fun in the rainy autumn days, then the robot can go out and walk the dog. So I think that kind of technology we will have in 10 years.
And how do you see the evolution of robots and even humanoid robots? Where will we see them first? I mean, like we have them in dangerous places, we have them in rescue. So how do you see the steps here?
Now it's in dangerous places in the industry as well, manufacturing industry. We will see them in the future more and more in transportation sector. If we classify a car as a robot, which I do. And then we will see them in healthcare. We already see some AI diagnostic systems and so on. We see them in surgery already now, so more and more in healthcare. And then I think also in restaurants, having robots at McDonald's flipping burgers and so on instead of humans.
That's actually not so far away.
Exactly. And we can then have restaurants open all night and every day a week and so on. And also cheaper, since we don't need to pay any salary for that.
Awesome. Fredrik, what's next in your life? What's happening privately, professionally? Something happening?
We are working more and more with robots and delivering more cool robots for big companies like Ericsson, Siemens and such. Also, this Metaverse is evolving more and more, and we are maybe taking in more venture capital. We don't have any venture capital now, but I'm looking for it this year. And
For which company?
For the Metaverse company. I think there we need to speed up the development more. In the robotics sector, I more calm that we are in a good position for the rise in the next 10 years. But Metaverse, the hype is now. We need to
surf the hype.
Yes. And also, I hope that my personal life will also, like having a family and so on, in the next maybe 5-10 years and so on.
Yeah, sounds awesome.
We had one question we never took, but we take it afterward. We need to talk.
Well, I think we have 20.
We have 20, but I thought we were going to do singularity on the show.
Next time.
Next time. Anyone that you would recommend to have on this show? Anyone that you would
I don't know which one you have already had, but Fredrik Heinz is really good. So that's one of my recommendation. Danica Kragic is also one.
Of course.
Good names.
Awesome names. I'm very eager to proceed with the after
exactly,
work now.
Me too.
So with that, awesome to have you here, Fredrik. As always, it's great discussions and very, very insightful comments.
Yeah, fantastic discussion, Fredrik.
Thanks for inviting me.
Thank you very much, Fredrik.